students, how are you? I think you all are okay. So now we should solve a very interesting problem. The problem is related to a sequence which is of recurrence equation, recurrence relation. So you will get an idea of recurrence. So let us come to the problem. The problem is how many regions are created by drawing 100 lines in a plane where no two lines are parallel and no three lines are concurrent. That means no three lines would pass on a fixed point. So you should understand the question more clearly. Suppose for an example, there are four lines in a region and we should see how many regions are created for four lines drawn. For example, suppose there is no line, the whole region is one and one line is drawn, then two regions are created, 1 and 2. So where the number of line is 1, then the number of region is 2. And suppose there are two lines, then the number of regions 1, 2, 3, 4. So 4 regions. And in this the three lines, the number of regions created 7. 1, 2, 3, 4, 5, 6, 7. So for number of lines when 3, the number of regions is 7. And for fourth line drawn, the number of regions is 8, 9, 10 and 11. So the number of regions are 11. So for the four lines, the number of regions 11. So we saw that for four lines, the number of regions 11. So in this way, we draw 100 lines, then how many regions would be created? That is the question, isn't it? When L equal to 100, then R equal to how many? So this is the question. So let us solve this question first from the very beginning. And now the question is number of regions created drawing lines in a plane. Suppose there is no line, then the region is 1, that is L equal to 0, R equal to 1, and L equal to 1, R equal to 2, L equal to 2, R equal to 4, L equal to 3, R equal to 7, L equal to 4, R equal to 11. So now for L equal to 0 and R equal to 1, we write 0 equal to 1. R0 means when L equal to 0, the number of regions. Similarly, R1 means when the number of line is 1, the number of region, that is R1 equal to 2. So similarly, R2 equal to 4, R3 equal to 7 and R4 equal to 11. So now see a very interesting relation between two consecutive values of the number of regions. Between R0 and R1, there is a relation. We may write 1 plus R0 equal to R1. How it is possible? Because 1 plus R0 means 1, so 1 plus 1 equal to 2, and 2 means R1, so we write 1 plus R0 equal to R1. Similarly, 2 plus R1 means 2 plus 2, 4. 4 means R2, so 2 plus R1 equal to R2. So in this way, we write 3 plus R2 equal to R3, 4 plus R3 equal to R4, and we see a diagonal relation between two consecutive equations. between two consecutive values of r, and from r1 plus r0 equal to r1, we write r1 equal to 1 plus r1 minus 1, and from 2 plus r1 equal to r2, we write r2 equal to 2 plus r2 minus 1, 3 plus r2 minus 3 plus r2 equal to r3, we write r3 equal to 3 plus r3 minus 1, and from r4 plus r3 equal to r4, we write r4 equal to 4 plus r4 minus 1. So if there are more number of values of L and R, there are more such equations we may write, and for nth term of R, what will we write? We write, just compare this, and we write Rn equal to n plus Rn minus 1, because if we put n equal to 1, then we get R1 equal to 1 plus R1 minus 1, and if we put n equal to 2, then we get the second equation, R2 equal to 2 plus R2 minus 1, and if we put n equal to 3, then we get R3 equal to 3 plus R3 minus 1. So in this way, by putting the value of n equal to 1, 2 up to n, then we get these all equations of recurrence relation. So these are the actual recurrence relation. This is the concept of recurrence for this sequence R. Now we have to solve this question from the beginning. If there is no line, region 1, and if one line is drawn, then regions is 1 and 2, so we'll on R2, and if two lines, then the regions are 4, so L equal to 2, R equal to 4. So in this way, if for three lines, the regions is 1, 2, 3, 4, 5, 6, 7, and for fourth line, that is for 4 lines, the regions created are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So when L equal to 4, R equal to 11. Now see the relation between two consecutive values of R and L. We have shown the bent arrow. See, there 1 plus 1 equal to 2, 2 plus 2 equal to 4, and 3 plus 4 equal to 7, and 4 plus 7 equal to 11. So if this rule follow, so we may get some other values of L and R in this way. L equal to 5. If L equal to 5, then R equal to 5 plus 11 is equal to 16. If L equal to 6, then R equal to 6 plus 16 is equal to 22. So in this way, we have got some values of L and R, and in this way, we get the sequence of R up to L equal to 0 to 7. Now we have to find out the nth term of the sequence R, and now we apply the difference method, because this sequence is belonging to a polynomial sequence. Polynomial means in its nth term, the expression of n will be like n square plus n plus 2 equal to plus 2, or n cube plus n or like this. These are called the polynomial of n. So we apply difference method. The sequence R difference method is nothing but we have to calculate the difference between the values of two consecutive R. Here the difference between 1 and 2, and between 2 and 4, and between 4 and 7. So we have to do this way. So now if we do the difference of the elements of the sequence R, then we get like this. The difference between 1 and 2 is 1, the difference between 2 and 4 is 2, the difference between 4 and 7 is 3. So in this 1 2 3 4 5 6 7, and if we do further difference, then we get 1 1 1 1 and 1. So here we see the second difference is 1. So from this situation we come to the decision that in its nth term of the sequence R, the maximum power of n is 2, because second difference is constant 1 1 1. So we may write the sequence R has n square, and what will be the coefficient? To find out the coefficient, you have to consider the values of the constant term. Here the values of the constant term is 1. We know that n square, the sequence n square has the value of second difference is 2, but here the values of the constant term comes 1 and 2 comes 1, that is 2 multiplied by half gives 1. So clearly half is the coefficient of n square, that is n square by 2, half into n square, that is n square by 2 will be the leading term of R. So the in the nth term of the sequence R, there is the term n square by 2. So now we have to subtract this n square by 2 from sequence R. Suppose if we subtract the sequence n square by 2 from the sequence R, and it will give the sequence C. So now we have to subtract the sequence n square by 2 from the sequence R. So sequence R, and sequence n square by 2 is nothing but 0 square by 2, 1 square by 2, 2 square by 2, etc. So now 0 square by 2 means 0, and 2 square 1 square by 2, next 1 square by 2 means 1 by 2, then comes 2 square by 2 means 4 by 2, then comes 3 square by 2 means 9 by 2, then 4 square by 2 means 16 by 2, and 5 square by 2, and 6 square by 2, then 7 square by 2. We have to subtract this. So we have to subtract 0 from 1, because we have to subtract the elements of n square by 2 from the elements of the sequence R. So now 1 minus 0 equal to 1. So 1 can be written as 2 by 2, and 2 minus half equal to 4 by 2 minus half equal to 3 by 2. So 3 by 2, and 4 minus 4 by 2 comes 4 by 2, then 7 minus 9 by 2 comes 5 by 2. So in this way 11 minus 16 by 2 equal to 6 by 2, 16 minus 25 by 2 equal to 7 by 2, 22 minus 36 by 2 equal to 8 by 2, and 29 minus 49 by 2 equal to 9 by 2. So if you minutely notice the sequence of C, then it is clearly seen that the sequence like 2 by 2, 3 by 2, 4 by 2, 5 by 2, 6 by 2, 7 by 2, 8 by 2, 9 by 2. So in this way, this sequence like n by 2, but it is not exactly n by 2. So because the sequence not started from 0 by 2 and 1 by 2, that means 0 and 1, these two elements are missing here. So this sequence is clearly not exactly n by 2, because we see the sequence n square by 2 starts from 0, and the sequence r starts from for l equal to 0, that means no line, that is n equal to 0. So so everywhere the sequence starts from 0. So here 0 by 2, that means 0, and 1 by 2, that means half, is are missing. So clearly the sequence is 2 plus n by 2, because if you put n equal to 0, then 2 plus 0 by 2 means 2 by 2 means 1, which is exactly seen the first term of the sequence C. And if we put n equal to 1, then 2 plus 1 by 2, that means 3 by 2, which is exactly seen in the sequence C. So 2 plus n by 2 exactly match the sequence C. So the sequence C is nothing but 2 plus n by 2. So now put this value of C in the equation. Sequence R minus n square by 2 is equal to C. R minus n square by 2 equal to C, and C is 2 plus n by 2. So changing the side of n square by 2, we get R equal to n square by 2 plus 12 plus n by 2, which gives R equal to n square plus n plus 2 by 2. So that is the nth term of the sequence R equal to this. And if we put the value n equal to 100, then we get the value of the number of regions, that is 100 square plus 100 plus 2 by 2, that means 5051. So this problem is solved by applying difference method. Now since this problem is recurrence relation, the sequence R has recurrence relation, so we may get the formula of R by applying recurrence relation. Let us go from the start. We get this value of L and R for 4 lines, and here R0, R1, R2, R3, R4. So we got this value. Now we know that relation between R0 and R1 is 1 plus R0 equal to R1, 2 plus R1 equal to R2, 3 plus R2 equal to R3, and 4 plus R3 equal to R4. So there are a diagonal relation between two consecutive equations, two consecutive terms of R, and here from this relation we get the general recurrence relation, that is Rn equal to n plus Rn minus 1, because putting the value of n equal to 1, 2, 3, 4, etc., we get the equation. So Rn equal to n plus Rn minus 1 is the general recurrence relation or equation of the sequence R. Now we have to find out the value of Rn in terms of n. So see, the recurrence relation Rn equal to Rn minus 1 plus n, and from this we get Rn minus 1 equal to n, and by using the Rn minus 1 equal to n, this equation, we get some relation. Putting the value as n equal to 1, we get R1 minus R0 equal to 1, R2 minus R1 equal to 2, and R3 minus R2 equal to 3, and R4 minus R3 equal to 4, and R5 minus R4 equal to 5, in this way. And lastly, dot dot, we may write in the top R0 equal to 1, also we write R0 equal to 1, and at the bottom we may write dot dot and then Rn minus 1 equal to n. And now we add all these equations of R1, R0, R2, R1, R3, R2, and so on, Rn minus 1 equal to n. Just we add this, and you see, very interesting, if we add this, then see, all diagonal position is the same, but their sign is different. That is R1, R1, R0, R0, R2, R2, all will be cancelled with each other, because R0 plus R0 minus, R1 plus R1 minus, R2 plus R2 minus. So in this way we have shown this. See this in very clearly, that all except Rn, all elements of R except Rn will be cancelled with each other. Here you see R5 and Rn minus 2. R5 will be cancelled when we had written the equation after R5 minus R4 equal to 5, then R5 will be cancelled. And if we had written the equation between Rn minus 1 minus Rn minus 2 equal to n minus 1, then also Rn minus 2 will be cancelled with plus Rn minus 2 in the top. So in this way, all values of R will be cancelled except Rn. So the left hand side of the result will be Rn, and right hand side, the blue colored one, extra 1, and after that the red colored 1 plus 2 plus 3 plus up to n. And we know that the red colored 1 to n is nothing but the sum of first n natural number, that is, we know that it will be n into n plus 1 by 2. So put this n into n plus 1 by 2, and we get 1 plus n into n plus 1 by 2, and thereafter we get Rn equal to 2 plus n square plus n by 2. By making 2 as LCM, we get this value. So in this way also we get the value of Rn in terms of n, which is the same as before. And if we put the value of n equal to 100, then for this question there are 100 lines. So if n equal to 100, then we can calculate the value of the number of regions, that means R, that is the same 100 square plus 100 plus 2 by 2 equal to 5051. So using the Rn minus 1 is equal to 1, that is the recurrence relation, we also find this value of the number of regions, that is the R. So the problem is solved. Thank you all. That's all.